Relation and function. This is the name of our chapter, name of the lecture. We will be exploring this in too much details. Whatever will be possible from my side, I will give 100% from myself. Yes, our focus will be on the discussion of relations and functions. Whatever will be important from this lecture will be told you. So, in a relation and function, class 11. You will learn the Cartesian product of sets along with the relation and functions. Cartesian product of sets. Do you know what is the Cartesian product of sets? Uh, we discussed about the Cartesian product of sets in the lecture of set. But again, it came because of there is a connection of this with the relation and function. We will understand relation and function with this Cartesian product of sets. Let's see. In our day-to-day life, in our day-to-day life, day-to-day life, where in our day-to-day life we have now the term relations. We have now the term relations in a pattern such as the relation between brothers and sisters. What are relations between brother and sister? You know very well. Husband and wife, or teacher and student. Same, same, same in math. Same in math. You will realize. Same in math. Same in math, the term relation is used to relate the numbers, symbols, variables, set, group of sets, etc. We will relate this with the other. For example, A is a subset. A is a subset of B. Denotes the relation of A and B. There is a relation of A with B. This is what is a relation of this A and B. If A is a subset of B, then hold on, it should be over here. Okay, now it should be over here. Now it will work very well. Here we have this. Uh, to tell here we are clear. For example, A is okay. A function is a kind of a relation. A function is a kind of relation which is operated between two quantities to yield output. In this article, we will provide you with the relation and function class 11 notes, so that it would be easier for you to learn and understand the concept. Okay. Thank you for this. Relation and functions. Relations and function. Relation and functions. It is taught in class 11, and this is the second chapter we know. Before we start learning about relation and function class 11, let us go through some basics of sets. Some basics of a set lecture. As we learned, a set is a collection of objects or elements. You have also learned about the empty set, universal set, types of a set, and all the other types in sets for class 11. Let us learn here the Cartesian product of sets. Cartesian product I am forgetting. As this concept will be used further to explain relation and function. This concept will be used to explain this relation and functions. To relation and function for class 11th. Okay. Now we are starting to understand Cartesian product of sets of sets. We have this Cartesian. Now in this, as you can see, Cartesian product of sets. This is what we this is the basic of a set. It will help us to understand relation and function. Suppose there are two non-empty sets. There are two non-empty sets. A non-empty, which means in a set has a something but not empty. So the Cartesian product of A. So the Cartesian product of A and B is the set of all ordered pair of elements. Yes, now I remembered. What? Here, look at here. What is happening here? It is telling you that this belongs to this and this belongs to this. This will belong to this and this will belong to this. Let's just see with example. Let a here what is happening. In this set we have 4 elements. In this set we have 2 elements, a1, a2, a3, a4. In this b1, b2. Now meaning of a Cartesian product of a set is we will take this, we will make a pair as a coordinate. From Cartesian you think of coordinate. So here we will make a coordinate like that. First of all we will take this, then 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 this, like that. We will make coordinates. It will happen when we will have something in a set. Then set should not be empty. Okay, crystal clear. Now this is clear. Example, let's us say x set has a b c and y set has a 1 2 3. What will happen now? We will take a comma 1. This is complete. This is one coordinate. Next coordinate a comma 2, then a comma 3, then b. Now we will start with this b comma 1, b comma 2, b comma 3, then c comma 1, c comma 2, c comma 3. This is what is a Cartesian product of sets. When it will come to Cartesian, you will have to be sure that yes, we are going to make coordinates. This set has 9 ordered pair. Of course you can count 1 2 3 4 5 6 7 8 9 pairs, 9 ordered pairs. We can also represent it as in tabular form. In this we have how much pair? 9 ordered pair. Okay, this set has 9. Okay, clear. Note, 2 ordered pair x and y are equal if and only if the corresponding first elements and second elements are equal. What is it saying? We will see it later. Now let's see what is a relation. Definition: a relation relation can be represented by R letter. A relation R is the subset. R is the here. This is a subset. A relation R is the subset of the Cartesian product of x into x, where x and y are two non-empty elements. It is derived by starting the relationship between the first element and the second element of the ordered pair x multiple y. This set of all primary elements of the ordered pair is called a domain of R, and the set of all second elements of the ordered pair is called range or R, a range of R. We will see. For two sets, we have two sets. For two sets, and here we have there's another set. Y is in this set has apple ball cat. Apple ball cat. The Cartesian product have how much? Cartesian product have 9 ordered pair. You can see this 1, this 2, this 3. Directly you can find how. Just multiply this by this, number of this by this, number of this by this. 3 3 is 9. You are getting what? Pair. Number of pairs and number of ordered pair are 9, which can be written as here x multiple y is equal to x multiple y is equal to what this is a Cartesian product of sets. This is how we represent subsets as a Cartesian product of a subset. X into y, here we are saying this is 1, and like that we will get 9 pairs. 1 2 3 4 5 6 7 8 9. We have 9 pairs. With this we can obtain a subset x multiple y by introducing a relation R between the elements of x and y, as R is equal to, here we are saying relation. This is what the set A comma B. Column A is the first letter of the word B. So A belongs to x and B belongs to y. A is the first letter of the word B. Even I didn't understand. Therefore, the relation between x and y can be represented as R is equal to, this is a set. This is a set, and then in this set we have separate A and this we have this coordinate A comma apple, then B comma ball, C comma cat. Example, let x A comma B and y C comma D. Find the number of relations from x to y. X into, here would be what? A multiple C, then A multiple D, A comma D, B comma C, B comma D. This is a Cartesian product of sets. Now number of a subset, we have n, then x multiple y is equal to 2 raised to power 4. 2 raised to power 4. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. Therefore, the number of relation from x to y is this much. Functions, a relation f is said to be a function. It will work. Relation will work if every element of a non-empty set X has only one image or range to a non-empty set Y. or if f is the function from x to y and x comma y belongs to function, then f(x) is equal to y, where y is the image of x. Under function f and x is the pre-image of y. Under f it is denoted as, example, n be this set of natural numbers and the relation r be defined as. Okay, let's explore it in details. Even I difference between, hold on, relation and functions. Relation and functions are the most important topics in the algebra. Relation and functions, these are the two different words having different meaning mathematically. You might get confused about their difference. Before we go deeper, let's understand the difference between both with a simple example. Okay, we are free to understand it. An order pair is represented as input then output, input comma output. Okay, this is the order pair, this is the coordinate. Now the relation shows the relationship between input and output. Okay, relationship. Whereas a function is a relation, function is a relation which drives one output for each given input. Let's see. All functions are relations, but not all functions are not a relation. Not all relations are function. All functions are relation, but not all relation would be function. Here we have this relation. In this relation, it is telling you functions are relation, functions are relation, functions are relations, but relations are not a function, but not all relations would be function. This figure is telling you. And in this section you will find the basic of the topic, definition of a function and relation, a special functions, different types of relation, and some of this solved cases. What is a function? A function is a relation which describes that there should be only one output for each input. Okay, we can say that a special kind of relation is set of ordered pair which follows a rule. Every x value should be associated with only one y value is called a function. For example, we have this domain and this range. What is happening here? -1 and then -3, 1, 3, 3, 9. So this will be domain and this would be range, and this is what? This is a Cartesian product, -1 comma -3, 1 comma 3, 3 comma 9. Let us look the definition of a domain, range, and function. Domain is what? It is a collection of the first values in the ordered pair set of all input x values. It is telling you we have this ordered pair -1 comma -3, 1 comma 3, and 3 comma 9. So all these sides would be domain and all these sides would be range in the function. Range, it is a collection of the second values in the ordered pair set of all output. So you can consider this all input and this all output. This is x and this is y. Okay, we have understood about domain and range. About domain is also it is a collection of the first values in the ordered pair, and the range is also a collection of the second values of the ordered pair. Example, we have example in the relation -2 comma 3, 4 comma 5, 6 comma -5, 6 comma -5, 6 comma -5, -2 comma 3. Okay, this is what Cartesian product of a set. In this domain range is what? Domain range is a -2. Domain is a -2, 4, 6, -2, and range is a -5. Range is what? -5, then 3, then 5. Here the 3 and 3 are coming 2 times, but we will not take 2 times, only 1 time. And here 5, this -5 and 5 both are different. So 3, okay, 5, okay, -5, okay, 3 times, and here we have 4. Same here, -2, 6, -2, so -2 are 2 times, 2 times. So remember, this x would be domain, and this y would be range. Note, don't consider duplicate while writing the domain and range, and also write it in increasing order. Yes, increasing, it should be increasing. -2, this is a small, then greater would be greater to this would be 4, then ascending order, this is ascending order, it should be ascending order. Whether you are writing domain or hence, it doesn't matter, you will have to manage, you will have to decorate as a ascending order, in ascending order. Types of a function, terms of a function. So this was a relation, this is a relation. In this, from this relation we got a domain and a range. From this relation we got a domain and range, and we got relation from the Cartesian product of a mass. Cartesian product of the mass. Types of a function, let's explore it. In terms of relations, we can define the types of functions as one-to-one function or injective function. Let's see what is the definition of this. This is a type of a function, one-to-one function, or we can call it as an injective function. A function f p q is said to be one-to-one function if for each element of a p there is a distinct element of a q. Many to one. A function which maps two or more elements of a P to the same element of a set Q. Onto function or surjective function, a function for which every element of a set Q there is a pre-image in set P. One correspond of a bijective function. One to in details, I didn't understand about this. So here we have this. Here we have this. Hold on, a special functions in algebra: constant function, identity function, linear function, absolute value function, inverse function. What is the relation? First of all, let's explore this one-to-one function. One-to-one function basically denotes the mapping of two sets. A function G is a horizontal line test. One-to-one here basically denotes the mapping of two sets. A function G is 1 to the 1 if every element of the range of Z correspond to exactly one element of the domain of Z. 1 to 1 is also written as 1 to 1. A function f is a method which relates element values of one variable to the element values of another variable. Here we have a definition of examples. With the help of examples, we are going to learn about this function in details so that its concept could be easily understood. This concept is widely explained in class 11th and 12th syllabus. Apart from the one-to-one function, there are other sets of a function which denote the relation between sets, elements, or identities. They are many-to-one function, or surjective function, or to function, or bijective function. Let's visualize it. Definition of a one-to-one function. A function has many types, and one of the most common function used in the one-to-one function or in injective function. Also, we will be learning here the inverse of this function. Here, this is one-to-one function. One-to-one function. This is linked with this, this is linked with this, this is linked with this, this is linked with this. This is known as one-to-one function. Domain to range, domain to range, domain to range, one-to-one function. This is what one-to-one function. One-to-one function define that each element of one set, say set A, is mapped with a unique element of another set, say set B. It could be defined as each element. It could be defined as each element of set A has a unique element on set B. Okay. An adjective function or one-to-one function is a function that maps a distinct. Okay. The below figure shows two functions, where first is a one-to-one function and second is a not an adjective function, many one function. Here one-to-one, this is linked, and here not one-to-one, this is not linked one-to-one. Here we can see what is happening. Here we can see there this is not linked with any of this, so this will not be adjective, and this is adjective one-to-one function. We have examples. The identity, okay, X is always one-to-one graph, horizontal and test. Constant function, what is a relation? It is a subset of the Cartesian. It is a subset of the Cartesian product, or simplify a bunch of points ordered pair. The relation between two sets is defined as the collection of the ordered pair. Relation between two sets is defined as the collection of the ordered pair. Just ordered pair of the two sets is a relation in which the ordered pair is formed by the object from each set. Here example we have this minus 2 comma 1. This is what is a relation between two. This is a relation between two sets. Two sets is only written in a set notation from with curly brackets. Curly brackets. A relation representation. There are other ways to write the relation apart from set notation, such as through tablets plotting it on xy axis or through mapping diagram. A relation in table. Here this is how we can represent a relation of one set and b set, two sets. Here this side is what x, this side is a domain, this side is a range, and together is what is a relation. Same here, this is a relation in graph, this is a relation in graph. Here 1 minus 2, where minus 2, this is minus 2, then 1 here, this 1, so minus 2, and then minus 2 again, then 0, then 1, then 3. Now 1 where 1, this 1, this 1, this 1, where 3, this is 3, this is 3, I am talking about this 3, this is 3, minus 3, this 4, y, so this is 4, and 1, this 1, y. This is how we represent relation on graph. Now in this relation in mapping diagram, let's see here. Here we have this minus 2 to 3, minus 2 to 3, minus 2 to 1, Okay, 0 comma minus 3, 0 comma minus 3, 0 comma minus 3. Here minus 2 comma 1, so minus 2 comma 1, minus 2 comma 3, so minus 2 comma 3, 0 comma 3, 0 comma 3, 1 comma 4, okay, 1 comma 4, 3 comma 4, 3 comma 3 comma 4, not 3 comma 4, 3 comma 1. That is how we represent relations in mapping diagram. Now I am crystal clear about the relations, but not about the functions, Types of relations, we are exploring it in details. Types of functions. There are different types of relations. Here we have empathy relations, universal relations, identity relations, inverse relations, reflexive relations, symmetric relations, transitive relations. Let's explore one by one. Then let's discuss all the types of one by one. We are starting from empathy relation, where there is no element. When there is no element of a set X is related or mapped to any element of X, then the relation in A is an empathy relation. If a set has a empathy, then relation would be empathy. That's it. Universal, which means R is a relation in a set. Let's say A is a universal relation because in this full relation, every element of A every element of A is related to every element of A. Every element of A to every element of A multiple A. This is what is a universal relation. Identity relation. If every element of set A is related to itself only, it is called identity relation. Here you can see A comma A. So relation would be what? This as it would be relation A comma A. This is what is an identity relation. It's a cell. For example, when we throw a dice, the total number of possible outcomes is a 36. 1, 1, 2, 1, 3. From this, if we consider the relation 1, 2, it is an identity. 1, 1, 2, 2, 3, 3, 3, 3. So this same, if X and Y are same, this would be identity relation. Did you observe something? If X and Y both are same, both are looking same, then this would be identity relation. What is the inverse relation? If R is a relation from set A to set B, R belongs to X, R belongs to A into B, the relation R reverse would be what? B comma A. So just the reverse of this would be what? A comma B, and it belongs to relation. So just a reverse of this would be A comma B. This is what inverse relation. For example, if you throw a dice, if R relation is what? 1, 2, 2, 3. So 1, 2 came. So of course this is what a relation 1, 2, 2, 3. This is not inverse relation. So opposite of this would be what? Opposite of this would be 2, 1 and 3, 2. This is a what? This is an inverse relation. Here the domain is the range. Domain is the range, yes, and raise here this 1, 2 is the domain. This was a domain. Now it is what? 1, 2. It became a range. This domain became range, and now 2, 3 is here. 2, 3 is what? Range. Now here 2, 3 became domain. This can happen when you have inverse relation. Then now next we have a reflexive relation. Let's explore it also. A reflexive relation. A relation is a, hold on, a reflexive word. We have a reflexive word. A relation is a reflexive relation if every element of set A maps to itself. For example, for every A belongs to A and A comma A belongs to R. I didn't understand. Symmetric relation. A symmetric relation is a relation R on a set A if A comma B belongs to R, then B comma A belongs to R for all. Okay, transitive relation. A comma B belongs to R, B comma C belongs to R, then A comma C also belongs to R for all ABC belongs to A, and this relation in set A is transitive. Okay. How to convert a relation into function? Example, we have this is a and is a function. If there are any duplicates or repetition in the x value, the relation is not a function. Repetitive number. There should not be repetitive domain and range. But there is a twist here. Look at the following example. What is coming? This is coming to so here is a repeating. Though x values are getting repeated here, still it is a function because they are associating with the same values of y. Yeah, okay, both are same. The point of 1 comma 5 is repeated here twice and here twice, and 3 comma minus 8 is written thrice. We can rewrite it by writing a single copy of the repeated ordered pair. So A is a function. Just we can ignore this completely, this, but it is a function. It is a function. Let's explore more about this. Difference between relation and function. Let's see. Relation and function. Here, which contain an object from one set to the another set. For instance, x and y are two sets. A is the object from set A, set x, and B is the object from set y. Then we can say that the objects are related to each other if the order pair A comma B is to be in a relation. The functions, the relation that defines the set of inputs to the set of outputs is called the function. In function, domain range, both are making a function, domain and range. In function, each input in set X has exactly one output. In a function, each input in set has exactly one output in set Y. Not all functions are relations, but all relations are not functions. What is the difference between relation and function? This is what we want to know. So differentiation, differentiating parameters, relations, functions. A relation is a relationship. A relation is a relationship between sets of values, okay, or it is a subset of the Cartesian product, okay. So what about a function? A function is a relation. We create a relation by the help of a Cartesian product of a subset, but we create a function by the help of a relation. This is what is the difference between this. A function is a relation. A function is a relation with only one output, for each input. Denotation. A relation is denoted by R, and it will be represented by f, a small f. This would be lowercase. Example, here we have this relation 2 comma x, 9 comma y, 2 comma z. This is the order pair. It is not a function, as 2 is input. 2 is input for both x and z. So it is impossible. This range also should be same in this, but here both are different. So this is not a function. Here function would be what? 2 comma x, 9 comma y, and 5 comma x. So here 5. Domain. So remember, here domains are different, but ranges are same. This only this range. Not every relation is a function. Is not a function. Every relation is not a function. Every function is a relation. This would be relation. This would be relation. Check out more difference between articles. Difference between rational and irrational. Difference between function and rational function. Difference between codomain and range. Difference between natural and whole number. Let's explore it. Codomain and range. Let's see what is the difference between codomain and range. So I think difference between codomain and range, it is referred to as a range of a function along with a few additional values. Solved. Okay. I think we will have to take I will have to take a class on this chapter so that I can be crystal clear. This was just a overview of this lecture so that I can understand during the lecture. Now I am going to select other chapter in this. We have next which is a trigonometric function for class this. Let's explore this trigonometric functions. Notes are provided here, all the topics close. Okay. In this we will see introduction of trigonometric function, angles, about angles, trigonometric functions of a sum and the difference of two angles. All this will be covered in this. Let's start with the introduction to trigonometry. The word trigonometry is derived from the Greek word trigon, which means trigon, which means angles, metron, which means measure, which means measuring the sides of a triangle. Trigonometry is a branch of mathematics which helps to study the relationship between the angles and sides, By this chapter, from this chapter, we understand relation between angles and sides. In the earlier class, we have learned the different trigonometric ratios of the right angles. In trigonometric functions, class 11, we are going to study the generalized concept of trigonometric functions and their properties. We will click on this link later, but first of all, let's complete this. Angles. What is angle? How would you like to explain it? How would you like to explain it about angle? An angle is a measure which gives the rotation of a ray about its initial position. In other words, the measurement of an angle is the amount of rotation. How much was rotated with the help of two lines. An angle is the amount of rotation performed to obtain the terminal side from the initial side. Last side would be terminal side and the initial would be first side. So we will see what amount of rotation, amount of rotating. This is what we will consider. We consider from this angle. The angle can be measured in two different ways. Let's see those different ways, such as degrees. If the rotation of the ray from the initial to the terminal side is how much? 1 upon 360 of the revolution, then the angle is considered to have a measure of 1 degree. This is how we represent 1 degree. We are saying this rotated like that much, this much, this much. That's it. Radians we have. So here we are understanding how to measure angles. So angles can be measured into two different. First is degree and second is radians. The angle subtended at the center by an arc length of 1 unit in a unit circle is considered to have a measure of 1 radian. Relation between degree and radian, as we know that the circle subtends at the center of the angle, was the radian measures 2 pi. Yes, 2 pi, then just a gap, just a small gap, and its degree measures 360. So 2 pi, 1 pi, then just below the 1 pi is what second next pi, so would be total 2 pi. 2 pi is just a circle and 360 is also circle. Hence we get 2 pi is equal to 360. How? 2 multiple 180 would be what? 2 multiple 180 is what? 360. So 2 pi is a radian and 360 is a degree. Or pi radian is equal to 180 degree. Therefore 1 radian would be 180 upon pi. 180 upon pi. Hence 2 pi. Hence 1 radian, okay, approximately 1 degree can be written as, okay, this much radians approximately. Trigonometric functions. The trigonometric functions are also called the angle functions, which relate the angles and the ratios of the sides of the right angle triangle considering the unit circle. The 6 important trigonometric functions are given as below as follows. If n is an integer, then sin x is equal to 0. Here cos x would be equal to 0. The other trigonometric function in terms of a sine and cosine functions are given as tan x is equal to, we know that tan x is equal to sin x upon cos x. Sin x upon cos x we know. And same with this, cosec x is equal to 1 upon sin x, sec x is equal to 1 upon cos x, cot x is equal to cos x upon sin x. We already know, we are familiar with this. Sum and the difference of two angles. Some of it, some of the important expression for the trigonometric function of the sum and the difference of two angles and related expressions are given as follows. Here we can write it as it can be written as minus sin x. Same here, cos minus x can be written as like that. So remember, sine, if there is a sine, this would be as it. There is a cos, it would be opposite. This would be reciprocal. Here, what is the formula of this? Cos x plus y. So it is just cos x into cos y, then plus sin x into sin y. Same here, cos x into cos y, then plus sin x into sin y. Then next we have cos pi upon 2 minus x is equal to sin x. Okay, this much formulas. There are a lot of formulas. Okay, this much formula you will have to remember by visualizing. Trigonometric functions are also known as circular function. Can be simply defined as the function of an angle of a triangle. It means that the relationship between the angles and side of a triangle are given by these trig functions. The basic trigonometric functions are what basics: sine, cosine, tangent, cotangent, secant, and cosecant. These are basic functions. It is read as a trigonometric identity. Read trigonometric identity. We will see it later. Table of contents. Table of contents. Sine, cosine, tangent. What is a sine? Tan function. We are familiar. Even odd function. This is a table of a content. There are a number of trigonometric functions and identities that denotes the relation between the functions and help to find the angles of the triangle. All these trigonometric functions with their formula are explained here elaborately to make them understand to the readers. You will come across the table where the value of this ratio is mentioned for some particular degrees, and based on this table you will be able to solve many trigonometric examples and problems. 6 trigonometric functions. We know sine, cosine. We know this 6 trigonometric functions. We know. We have this figure. This is a perpendicular, this is a base, and this is a hypotenuse. We are familiar with this. Something new. Sine function of a angle is the ratio between the opposite side. So it is giving you a amount of rotation. Sine function. This is opposite. We were talking about this sine, then cosine, tangent. All these are basic functions of a trigonometric, as we know. If we click on this sign, then we come to this sine function of an angle is a ratio between opposite side to that of the hypotenuse. Here we are getting a amount of rotation which is just opposite upon hypotenuse. Here we have this. If we take this angle, then opposite of this would be perpendicular and this would be base. This would be, and here it is a fixed, hypotenuse is a fixed already. This is a very basic cos function. Second formulas, we have formulas. These are formulas that we have discussed, we have seen in 10th class. Even and odd function, just look at this, what is it? Here we have the cos and sec functions are even functions, the rest other functions are odd function. Cos and sec, and accept this, all are odd function. Cos and sec. Sine is a what? Sine is a odd. Cos is a even. Tan is a odd. Cot is a odd. Cosec is also odd, but sec would be even. Periodic function, the trig functions are periodic function. The smallest periodic cycle is a 2 pi, but for tangent and the cotangent it is a pi. Why n is any integer? These are formulas. Let's explore something else. This is a basic about trigonometric. Let's see something else. We have a complex number. Linear inequalities. This is a what? This is a linear inequalities. Complex number. Let's explore complex number. A complex number is just an imaginary number. Imaginary number that cannot be obtained, that cannot be plotted on a number line is an imaginary number. I is an imaginary complex number. A number that can be represented in the form p plus iq is defined as a complex. P would be a pure number that can be represented on a number line, but iq would not be pure number, it would be imaginary number. Here p and q are real numbers. But I is not a real number. I is unreal number. For a complex number, z is equal to p plus complex is represented by z. Z is equal to p plus iq is known as the real part, represented by r is z, real z, and q is known as the imaginary part. Here z is q is known as the imaginary part because this is a part of the imaginary. It is represented by I and z of the complex number. Here we will start with the introduction of a complex number, then we will see complex numbers, algebra of a complex number. We have this is a table of contents. Let's start from this. Complex number. Now from here we will start. This is a table of contents. It is a complete. Now let's start. Here complex number are the number that this is also number, but it is different from the real number, rational number, irrational number. Complex number are the numbers that are expressed that are expressed in the form of a plus ib. A is a real number, b is also real number, but b is a part of imaginary, where a b are real numbers and I is an imaginary number called iota. I is also called iota. The value of I is what? Root minus 1. This is what is the value of I. For example, 2 plus 3i. So here would be what? Root minus 3. Root minus 3 is a complex number where 2 is a real number, Re, and 3i is a imaginary number. Imaginary number, IM. We represent it IM, and this RE, real number. Combination of both the real number and imaginary number will make a complex number. Example of complex number I plus j. Here we have a real number and one is an imaginary number. So that's why this is a complete complex number. Next we have here. Next we have here over here we have this. So in this we have what? A real number, and this is what? This is a imaginary number. Here this is a real number and this is a imaginary number. Here this is a real number and this is a imaginary number. So imaginary number is usually represented by I or j. You can represent imaginary by I or j. It is to you. It is up to you. Which is equal to this much value. Which is equal to this much value. Therefore, the square of the imaginary number gives a negative value. Yes, it will give you a square of imaginary will give you minus 1. Minus 1. The main application of this number is to represent the periodic motion such as water waves, alternative current. The main application of this number is to represent periodic motions such as water waves, alternative current, light waves. All this complex number will help in understanding of water waves, alternative current, light waves, etc., which rely on sine or cosine waves, etc. Okay, we will see. Not very definition. We have this contents of this lecture: definition, absolute value, algebraic operation, formulas, power of iota, identities, properties, modulus, and conjugate. All this will be discussed. We know what is a complex number. Now complex number, let's visualize it. Here we have this. What is happening here? This, as you can see, this we have a real part. This is a real part of a complex number, and this only b is a this real part is a this is a part of a complex, and this b is also real number, which is a part of a complex number. Here I is an imaginary part, and this plus we are adding. So this is a complex number. Now what are real numbers? We know real numbers contains rational number and irrational number. What are imaginary number? The number which are not real are imaginary numbers. We can only imagine, just we can imagine. When we square an imaginary number, it gives a negative result. It is represented as Im. Example: this -2, -7, -11. All these are imaginary number. If you remove a minus, then it will become irrational number. Just here is a minus. Here is a minus with a 2, with a 7, with a minus, with 11. That's why it is a imaginary numbers. Now next we have the complex number were introduced to solve the equation x square plus 1. X square plus 1 is equal to 0. Okay, notation is what? Z is a Z is a symbol of representing complex number. Real number, imaginary numbers are 2i, 9i is a minus 9i, minus 6i is a purely imaginary. 0 is a purely real. 0i purely real. 6 is a real number. Is 0 a complex? As we know, 0 is a real, and real numbers are part of a complex number. There is a 0 is also complex number and can be represented as. So here remember, here it is telling you 6 is a complex number. Whether you don't have if you don't have a imaginary number in this, then okay, it doesn't matter, but 0 can be represented because 0i is what? 0i is a imaginary line and it becomes 0. So you can write 0 plus 6 plus 0i. Okay, a complex number can have imaginary line. Imaginary number cannot have imaginary number. It doesn't matter. Graphical representation. This is a graphical representation. This is a imaginary and this is a real number. X is a real number and this is a imaginary number line. Let's visualize one by one. Let us see an example here. If we have to plot a graph of a complex number 3 plus 4i, then okay, 3 plus 4i. Absolute value. Absolute. What is the meaning of absolute value? The absolute value of a real number is the number itself. The absolute value of x is represented by modulus. When we will apply modulus, then it will change the sign of a minus. So here you can see what is happening here. Here you can see what is happening. This is 3. This is 3. When we apply modulus with this, then it didn't convert plus sign into minus, but it will convert minus sign. Modulus will convert minus sign into plus. That is what will happen. Not this will not convert plus sign into minus. Only minus sign will be converted into plus by applying modulus. Now we have now in case of a complex number, finding the modulus has a different method. Suppose z is equal to x plus y. Y is a complex number, then mod of z will be what? Same as it, because in z we don't have negative. Now next. Okay, algebraic operators on complex number. We have addition, subtraction, multiplication, division. Okay, roots of a complex number: 2 distinct real roots, similar roots, no real roots. Addition, complex number formulas, addition, like that we add. Whatever we left, we will discuss all this later, one by one.